Angles. We have an archer over here who is trying to hit the bullseye. If the arrow is parallel to the ground, it hits the bullseye. If the arrow is tilted with respect to the ground, it hits the other circles. The circle which the arrow hits is dependent upon the extent to which the arrow is tilted. Thus, if the case when the arrow is parallel to the ground is considered as the initial ray, and the case when the arrow hits one of the other circles as the terminal ray, then we can say that an angle is the measurement of the extent of rotation of the terminal ray with respect to the initial ray. Definition. Angle is a measure of rotation of a given ray about its initial point. The original ray is called the initial side, and the final position of the ray after rotation is called the terminal side of the angle. The point of rotation is called the vertex. We can see the initial side, the terminal side, and the vertex in the diagram shown here. The angle is considered to be a positive angle if the rotation of the terminal ray from the initial ray is in the anti-clockwise direction. The angle is considered to be a negative angle if the rotation of the terminal ray from the initial ray is in the clockwise direction. There are various units of angle that are used. They are as follows. 1. One complete revolution from the position of the initial side. This is used for measurement of large angles. 2. Degree measure, and 3. Radian measure. Degree measure. Let us take a circle with center O and divide it into 4 equal parts. AB and CD are the diameters which are perpendicular to each other. Concentrate only on the part COB. Now we divide COB into 9 equal parts as shown in the figure. Let us take one of those 9 parts, say EOB, and divide it into 10 parts. Now, the angle shown in the highlighted part in the figure is called 1 degree, and it is denoted as shown here. The above process of division of the circle can be shown mathematically as follows. First, the circle is divided into 4 equal parts, then 9 equal parts, and then 10 equal parts. Therefore, we have divided the circle into 4 into 9 into 10, which is equal to 360 parts. Thus, 1 degree can be defined as 1 by 360th part of a circle. A degree is divided into 60 minutes, and a minute is divided into 60 seconds. 1/60th of a degree is called a minute, which is written as 1 dash, and 1/60th of a minute is called a second, written as 1 double dash. Thus, 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Radian measure. Consider a unit circle with center O. The angle subtended at the center by an arc of length 1 unit in a unit circle is said to have a measure of 1 radian. Radian measure. We know that the circumference of a circle of radius 1 unit is 2 pi. Thus, 1 complete revolution of the initial side subtends an angle of 2 pi radian. The result that we have obtained can be generalized for any circle. In a circle of radius r, an arc of length r will subtend an angle of 1 radian. Thus, for an arc of length L in a circle having radius r, the angle that it will subtend at the center will be equal to L into 1 upon r, which is equal to L by r. Thus, if in a circle of radius r, an arc of length L subtends an angle theta radian at the center, we have theta is equal to L by r.
Relation between radian and real numbers. Let us draw a unit circle on a grid. Here the center lies on the origin. We've already studied in the previous classes that the length of an arc of a circle will give the radian measure of the angle which the arc will subtend at the center of the circle. For both the positive and negative real values, we have a corresponding angle subtended at the center. Thus, radian measures and real numbers can be considered as one and the same.
Relation between degrees and radian. Let us consider a clock. The minute hand of a clock covers 360 degrees in 60 minutes. Now, if we measure the angle in radians, the minute's hand covers 2 pi radians in 60 minutes. From the above two statements, we can deduce that 2 pi is equal to 360 degrees. Therefore, pi is equal to 360 degrees by 2, which is equal to 180 degrees. So, pi is equal to 180 degrees. Now, let us tabulate the relation between degree measures and radian measures of some common angles. So 2 pi is equal to 360 degrees, or 360 degrees is equal to 2 pi. Therefore, 30 degrees is equal to 2 pi by 360 degrees into 30 degrees. This is equal to pi by 6. So the radian measure of 30 degrees is pi by 6. In a similar fashion, 45 degrees is equal to 2 pi by 360 degrees into 45 degrees, which is equal to pi by 4. So 45 degrees is equal to pi by 4 radian. 60 degrees is equal to 2 pi by 360 degrees into 60 degrees. This is equal to pi by 3. So 60 degrees is equal to pi by 3 radian. 90 degrees is equal to 2 pi by 360 degrees into 90 degrees, which is equal to pi by 2. So 90 degrees is equal to pi by 2 radians. Again, 180 degrees is equal to 2 pi by 360 degrees into 180 degrees. Therefore, 180 degrees is equal to pi radian. 270 degrees is equal to 2 pi by 360 degrees into 270 degrees, which is equal to 3 pi by 2 radians. 360 degrees is equal to 2 pi by 360 degrees into 360 degrees, which is equal to 2 pi. Since angles are measured either in degrees or in radians, we adopt the convention that whenever we write angle theta degrees, we mean the angle whose degree measure is theta. And whenever we write angle beta, we mean the angle whose radian measure is beta. Note that when an angle is expressed in radians, the word radian is frequently omitted. Thus, pi equal to 180 degrees is written with the understanding that pi is radian measure. Thus, radian measure is equal to pi by 180 into degree measure, and degree measure is equal to 180 by pi into radian measure degrees. Example 1. Convert 30 degrees 40 minutes into radian measure. Solution. 30 degrees 40 minutes can be written as 30 2 by 3 degrees. Now we know that 180 degrees is equal to pi radians. So I degrees is equal to pi by 180 into I radians. So 32 by 3 degrees is equal to pi by 180 degrees into 92 by 3, which is equal to 92 pi by 540 radians. Simplifying this, we get 30 degrees 40 minutes is equal to 23 pi by 135 radians. Example 2. Convert 14 radians into degree measure. Solution. We know that pi radians is equal to 180 degrees. Therefore, 1 radian is equal to 180 degrees upon pi into 1 degree. Therefore, 14 radians is equal to 180 degrees upon pi into 14 degrees. We know that pi is equal to 22 by 7. Therefore, 14 radians is equal to 180 degrees by 22 into 7 into 14. This is equal to 8820 degrees divided by 11, which is equal to 801 9 by 11 degrees. Now we shall convert 9 by 11 degrees into minutes. So 14 radians is equal to 801 degrees plus 9 into 60 by 11 minutes. So 14 radians, this is equal to 801 degrees 49.09 minutes. Therefore, 14 radians is equal to 801 degrees 49.09 minutes.
Example 3. Find the radius of the circle in which a central angle of 30 degrees intercepts an arc of length 44 centimeters. Use pi is equal to 22 by 7. If in a circle of radius r an arc of length L subtends an angle theta radian at the center, we have theta is equal to L by r, or L is equal to r theta. Now L in this case is given to us as 44 centimeters and theta is equal to 30 degrees. We convert theta into radians. So 30 degrees is pi by 6 radians. Therefore theta is equal to pi by 6 radians. Now r is equal to L by theta. Therefore this gives us 44 into 6 by pi. We know that pi is equal to 22 by 7 and we substitute this value. So we get r is equal to 44 into 6 into 7 divided by 22. Simplify this and we get 84 centimeters. Therefore the radius of the circle is equal to 84 centimeters. Example 4. The minute hand of a watch is 1.4 centimeters long. How far does the tip move in 30 minutes? Use pi as 22 by 7. A minute hand covers 360 degrees in 60 minutes. Therefore, 60 minutes is equal to 360 degrees. Therefore, 1 minute will be equal to 360 upon 60 into 1. Therefore, in 30 minutes, we have 30 into 360 divided by 60, which gives us 180 degrees. So the minute hand covers pi radians in 30 minutes. Now radius is equal to 1.4 centimeters. Now the length of the minute hand as given in the question is 1.4 centimeters. Now let's recall our basic concept. If in a circle of radius r, an arc of length L subtends an angle theta radian at the center, we have L is equal to r theta. Therefore, we get L is equal to 1.4 into pi. This is equal to 22 by 7. So we get 1.4 into 22 by 7, which finally gives us 4.4 centimeters. Hence the length covered by the minute hand of the watch in 30 minutes is 4.4 centimeters. If the arcs of the same lengths in two circles subtend angles 40 degrees and 200 degrees at the center, find the ratio of their radii. If in a circle of radius r, an arc of length L subtends an angle theta radian at the center, we have theta is equal to L upon r, or L is equal to r theta. Now we know that L1 is equal to L2, so theta 1 is equal to 40 degrees. which is equal to 4 pi by 18 radians. Theta 2 is equal to 200 degrees, which is equal to 20 pi by 18 radians. Let L be the length of each of the arc. Then L is equal to R1 theta 1, which is equal to R2 theta 2. Substituting the values of theta, we get R1 4 pi by 18 is equal to R2 20 pi by 18. This gives us R1 upon R2 is equal to 5:1. Therefore, R1 is to R2 is equal to 5:1.